All right, here's a quick recap of point slope form of a line. If you're given a point, I want you guys to always label them x1, y1, or label it x1, y1. And then our slope, of course, is always our m value. And this is the formula that we use for point slope form. Y minus y1 equals m times x minus x1. So we've already gone over how to write the equation given a point and a slope. But what could we do if we're given 2 points instead and not the slope value? Well, all we need to do is use these 2 points to determine our slope first. And then we can use the point slope form of a line to write our equation. All right, so again, I always want you guys to label. So we can label our first point x1 with its corresponding y1 value. And then our second point can be x2, y2. And hopefully you remember the slope formula. It's m equals y2 minus y1 over x2 minus x1. Okay, this is the change in y over the change in x. The change in y over the change in x. It's our rise over our run. Okay, so if you don't have this formula memorized and you're trying to get ready for your STAR test, this is on your formula sheet. If you're outside the state of Texas, I'm not exactly sure which states give you this formula if you have a standardized test, but this is the formula that you would need to know. So let's sub in our values. Our slope, m, is going to be equal to, and I'm going to take my y values and subtract them, -6 minus -1. -6 minus -1. That's our numerator. And then our denominator is x2 minus x1. So 4 minus 2. 4 minus 2. All right, now remember in our last video, we talked about this. You never want to leave this kind of minus a negative. It's kind of a double negative sign. It actually means plus. If I'm subtracting negatives, I'm adding something. So -6 plus 1 gives us -5. And our denominator, of course, 4 minus 2 is just 2. So this is our slope. And of course, you can turn this into a decimal if you would like to. But again, because our slope gives us kind of our walking directions for our line, the change in y over the change in x, or our rise over our run, we typically like to leave it in fraction form. Now, we can use either of these points to write our equation, but because we already labeled our first point, x1, y1, we'll just go ahead and use that point to cut down on any confusion. So we've got y minus y1 is equal to our slope times x minus x1. And we can just sub in our values now. Y minus our y1 value, which was -1, equals our slope of -5/2 times x minus x1, which is just the number 2. And again, we do not want to leave this minus a negative value here. It really means plus. So I'm just going to go ahead and rewrite this as y plus 1 equals -5/2 times x minus 2. And that right there is the point slope form of the line that contains these 2 points. All right, so let's look at a table of values. Now you might prefer having this information a little bit more because we have multiple points to choose from. So if we know ahead of time that this is a linear relationship and not a quadratic or something different, we know this is linear, well, we can just use our rise over run method or the change in y over change in x. So again, our slope is going to equal some fractional value, the change in y over the change in x. Well, how do I move from positive 16 to 10? I subtract 6. Okay, well, what's my change in x? -3 to -1. In that case, I add 2. So we have -6 over +2. That represents the change in y over the change in x. So we get this fraction right here, -6 over +2, which of course we can just reduce those values and it gives us a -3. So just to double check and make sure that this is in fact linear, you can try another set of points. How do I move from 10 to the number 1? We subtract 9. Well, what's our change in x? From negative 1 to positive 2, we add 3. So this time, our change in y over our change in x is negative 9 over positive 3. So we have our slope is equal to negative 9 over a positive 3. And of course, when we simplify that, again, we still get a negative 3, showing that this is likely a linear relationship here. So we have our slope of negative 3. Now we have all of these choices, these points to choose from. So I'm just going to go ahead and choose this last point here at the bottom, but you can choose anything that you want to label x1 and its corresponding y1. So make sure that you use a point. Whoops, almost labeled that y2. There's y1. Make sure you choose an x and y value that go together in your table. And then we're just going to write the equation of our line in point slope form. So y minus y1 equals our slope times x minus x1. And we can just quickly sub in our values. Y minus, that y1 value is a negative 8. And that should equal our slope of negative 3 times our x value minus our x1, which is 5. And of course, we do not want to leave this minus a negative right here. So you can go ahead, or you should go ahead and change that to y plus 8 is equal to negative 3 times x minus 5. Okay, so that is how you write an equation in point slope form given a table. Now, what if you are given a graph? Now, my first instinct is to tell you guys, hey, just find your y-intercept and determine your slope, your rise over your run, so that you can just write it in slope-intercept form. But when I look at this y-intercept value, I don't know exactly what it is because it's not an integer value, right? My graph line is not crossing my y-axis at an integer, and I don't want to guess or estimate at this value. I want the exact equation of my line. So I'm going to have to do something different. I'm going to go ahead and use point slope form again. Okay, point slope form is y minus y1 equals our slope times x minus x1. And I have 2 points to choose from that are labeled on my graph, but I don't know what my slope is. So I am going to go ahead and start with this point right here, and I'm going to count my rise over my run. So 1, 2, 3, 4. I went up 4 steps, which makes that a positive 4. And now my run is 1, 2, 3, 4, 5, 6. A positive 6 because we're moving to the right. So our slope right here that we just determined is positive 4 over positive 6, right? Our rise over our run. It's always the change in y over the change in x. Now 4 over 6 can be reduced, of course. I can divide both of those values by 2, and I end up with a slope of 2/3. So I can use that as my slope value, but now I need to figure out which point I want to work with. And either point, it doesn't matter which one we choose, okay? So let's go ahead and label our point over here on the right. It has an x value of positive 4 and a y value of positive 1, so this is 4, 1. And of course, I want to label this x1 and y1. So let's sub in these values. We have y minus y1, which should equal our slope, which we decided was positive 2/3, times x minus our x1 value, which was a 4. And there's our equation in point slope form. Now, I know you might be asking yourselves, well, if I used this point down here, I would have completely different values in my x1, y1 locations, right? Well, again, there are many different ways to write the equation of this line. This just shows the relationship between the values, okay? So if I were to distribute my slope and then simplify this equation entirely into slope-intercept form, they would simplify down into the exact same equation. So we'll do that in our next video.